Hello, everyone. I've seen a lot of cool presentations today, and I think my presentation kind of, touches upon what Steve was saying about acceptance in terms of the industry, and they want some validation that you can use seawater concrete in replace of normal concrete. And at ICC-ES, this is where we fill that void. So I'm giving this presentation, but I also want to acknowledge my colleague, Munib. He's in the audience over there. He was the lead engineer on developing this acceptance criteria. So ICC-ES is actually a subsidiary of the International Code Council. The International Code Council does the IBC and the IRC. And in the IBC, there is section what was 104.11, but now in the 2024 IBC and later editions, it's 104.2.3. Doesn't roll off the tongue as well. But it is the section that allows you to use alternative materials, design, and methods of construction and equipment. And so our role at Valuation Service at ES is that we certify these building products to ensure that they comply with the intent of the code and with respect to quality, strength, effectiveness, durability, safety, and fire safety. So since seawater concrete is not recognized in ACI 318, which is referenced by Chapter 19 of the IBC, therefore it falls within this category of alternative materials. So I just wanted to first talk about our acceptance criteria process. So our acceptance criteria process is actually starts with the collaboration between us, the staff members, and the report applicants, and any industry leaders that are interested in being part of that process. We develop a document, we think, what is the acceptance criteria for this material? And then after we draft it up, we post it on our website for public commenting. Anyone can come, read the document, post their comments, and then we address each of the comments. And then eventually that document comes down to an evaluation committee hearing. This evaluation committee hearing happens 3 times a year, February, June, and November. And the process before each hearing starts about 6 months before the hearing. So if you have an alternative material like seawater, you want you have a project, you need an evaluation report, certification on it in 2 months, but we don't have an acceptance criteria, you're going to have to wait a bit. So this is why it's good to get ahead of the curve before you start doing any projects to make sure there is some type of criteria that you can get certification for before you start your project. And the evaluation committee hearing is made up of building officials, engineers across the U.S. And at the hearing, you present the acceptance criteria, and then proponents and opponents can present their comments on it. And eventually, there's a decision, acceptance or acceptance with some changes, or come back and make some changes later. Okay. So that was the process for the seawater concrete. And on the left side, you see sort of like the contents of all our ACs, our general contents. So we have the purpose, where you list the codes and references, some basic information such as laboratory requirements, type of labeling you need, any type of information that you need to give to us so we can analyze it for a test plan. And then in the AC, there's a test performance requirements, test methods, and quality control. Now this is important because we're not just evaluating the performance of the product, but we're also evaluating the quality control of the product. Okay, so this is the title page of it. So the actual title is Acceptance Criteria for Seawater Concrete, Use in Plain or FRP Reinforced Concrete Members. And each of our ACs get a number. This is AC574. The parentheses of 24 just indicates that it is up to the 2024 IBC code. All right, so for the introduction of the acceptance criteria, we start with the purpose. The purpose of this acceptance criteria is to establish the requirements for the evaluation of concrete made with seawater. And so you can have reports, are what we call ICC-ES ESRs, evaluation service reports, to be evaluated under the following codes. So not just the IBC and the IRC, but we're also considering the Dubai Building Code, the DBC, as well as the Saudi Building Code, the SBC. And the reason we developed this is because, concrete made with seawater is not code compliant concrete. Okay, and the scope considers seawater as a mixing water for the production of hydraulic cement concrete, and it can be used for plain concrete or fiber reinforced polymer, FRP reinforced concrete. And this is seawater in replace of the code specified ASTM C1602 potable mixing water. And because, due to the seawater content, any conventional steel bars or steel anchorage inserts, anything with steel is outside the scope of this acceptance criteria. So before we get started into all the testing requirements, I want to define some notable definitions in the acceptance criteria, starting with the major environmental event. Obviously, the sea can change over time and due to different things that are happening. And so we define a major environmental event as something that can affect the chemical composition of the seawater source. So this is things like hurricanes or oil spills, or maybe a river mouth is near the seawater source and there's some flooding. Okay. And then here we have to define what seawater concrete is. It's very specific. It's concrete made with seawater. And then we also allow for seawater curing. So since, fresh water is scarce, it makes sense to cure your samples also with the seawater. And we had some debate about how do we define the seawater source, and so this is the definition we came up with. It is the combination of onshore location of the facility used to collect the seawater and the distance of the inlet collecting seawater from the shoreline. And a couple of other definitions. The reference sample is the concrete made with that potable water that's in accordance with ASTM C1602, as well as the property ratio. Property meaning compressive strength, flexural strength, length change, and time of setting. Okay, some important information about packaging, identification, and where you can do your testing. So there needs to be a description of the method of seawater source on the labeling, so such as the transportation truck bill. Also, with all our ESRs, the labeling must have our ESR number on it. So that's just to show that it's been certified by ICC-ES. The testing lab has to comply with ISO 17025, and the lab has to be not just accredited to ISO 1705, but it has to be accredited for those ASTM standards. Now, we do have an acceptance criteria on test reports, AC85, where there is a section 2.2, where if you've done testing at a non-accredited laboratory, we have a process where we could do some, like a one-time accreditation, or you can justify that your testing is because, for graduate students, for example, doing a lot of testing in the university labs, they have the knowledge to test in accordance to these ASTM standards. Test reports must be in accordance with section 7.8 of ISO 17025, and the sampling. So again, this is from AC85. We have two options for sampling, either mandatory sampling, meaning that the accredited lab comes to your manufacturing location, takes the samples or witnesses you taking the samples and brings them back to the lab to test, or we have optional. And so we're allowing optional sampling. If you don't have the accredited lab sample your product, then you have to write a declaration declaring that the product that was tested is equivalent to the product that's being manufactured. Okay, we allow all different types of cement, not all different types, but we allow these following cements. The cements that comply with section 26.4.1.1A of ACI 318-19, as referenced by chapter 19 of the IBC. We're still using the 19 of 318 just because 2024 IBC only references the 19. And once 27 IBC comes out, we'll reference the 25 ACI 318. You can also have an evaluation report under AC459, which is our acceptance criteria for proprietary hydraulic cement, as well as AC529, which is our acceptance criteria for low carbon alternative cements for use in concrete. The FRP bars, so for structural purposes, they either comply with 79, 57, and 440.11, or they can comply with D8505. They also can have an ESR with us, so AC454. And for non-structural purposes, they can have an ESR with us under our AC for 521, which is our acceptance criteria for FRP bars and meshes for non-structural concrete members. Aggregates. At this time, for normal weight concrete, we're just requiring ASTM C33, and for lightweight concrete, ASTM C330. The water to cement ratio has to be prepared at the maximum water cement ratio between 0.45 and 0.5. And we actually allow the fly ash limits that are given in section 26.4.2.2B1 of ACI 318-19 to be exceeded when the physical properties of concrete requirements of AC574 are met. So that is basically section 3.2, which is on standard curing of the samples. We also want to know if the seawater is being treated. So any seawater treatment used by the manufacturer shall be used in the samples tested and reported in the evaluation report. Okay, so the first testing requirement is the chemical composition of the seawater. And so to test the chemical composition of the seawater, we are requiring the following standards. So for the chloride sulfate content, ASTM D4327. For the sodium, magnesium, calcium, potassium, and other alkalis, ASTM D1976. The total dissolved solids is D5907, and then the pH can be measured either with D1293 or D5464. The seawater chemical composition is really important. It's in your quality control, and so this is to be reported on the ESR. So next up is our fresh properties. So we're requiring slump, fresh density, air content, initial and final time of setting, as well as bleeding. The number of specimens per mixed design should be 3, 1 per batch. And these are our acceptance criteria. So for slump, it's within 1 inch of the reference mixture. For fresh density, within 5% of the reference mixture. For air content, within 1% of the reference mixture. For time of setting, not 1 minute earlier or not 1 hour, 30 minutes later. And then bleeding is max 2% over the reference sample. Next is our hardened properties. And so we have, you can cure the specimens in potable water or seawater. So we have 2 options for this. And we want to, can't really see it, it's kind of cut off. This slide is a little cut off, but anyway, I'll just point out. So there's some footnotes on this testing matrix. For compressive strength, we are requiring testing at 3, 6, 7, 28, and 90 days, as well as 6 months and 1 year. So we want to ensure that within the first year of the seawater that there is no detriment to the compressive strength. And the acceptance criteria would be minimum of 90% of the reference sample. For flexural strength, we only are requiring 3, 7, and 28 days. But the same acceptance criteria as the compressive strength. We also look at, it's hard to read, but length change, freeze thaw, but only if you're in a region where you are required for freeze thaw, sulfate attack, and I think that's it. Oh yeah, ASR. Okay, so since this is for both IBC, IRC, but also the DBC and SBC, we allow some alternative standards to be used for some of the fresh and hardened properties. But if you do use these standards, they must be referenced in the evaluation report. We also give you optional, since this is not code compliant concrete, if you are wanting fire performance for fire rated construction and non-combustibility, we give you those options as well. And then for your quality control as well. So with the initial report, you do an initial qualifying inspection of the manufacturing location, and then we require surveillance inspection every year. The Seawater Quality Control Program, so the composition must be tested monthly and after every major environmental event. And then the seawater must have no foreign impurities within 5 times magnification. Mixing and placing of the concrete should be in accordance with 1705.1.1 and 1705.3 of the IBC. But if there's any special instructions from the producer, that should also be given. And this is my summary slide. So AC574 is the first way for developing certification for these seawater concrete mixes. And it's certification for compliance with the IBC, IRC, DBC, and SBC. It only applies to FRP reinforcement, steel reinforcement is outside the scope of this. And so I thank you for your attention. And if you have any questions, please let me know or let my colleague know.
I don't think we have time for questions maybe at the end, but right
Sure.
now I think, thank you very much.